So in this rule, we want to learn some basic rules, and a lot of this is just going to be practice, okay? Because the rules themselves are pretty simple. It's just a matter of memorizing them and knowing when and how to use them, okay? So with these four rules, I should say, you can find the derivative of any polynomial function and a number of other functions as well, but these are the rules that we would need. Okay, so first of all, and I want you to keep in mind the concept of the derivative. The derivative gives you the what of a function? The slope of the tangent line to a function at the point. Okay? It gives you slope, rate of change, all right? So, I want you to think here, if I have a line y equals 5, what's the slope of that line? 0. If I have y equals 7, the slope of that line is?
0.
So the derivative of a constant function is? 0. Okay? That's just a horizontal line. So the slope will be 0. Okay? Then you have x to a power. This is the power rule here. Okay? X to a power, notice what we end up doing is we take this power of n and we make it the coefficient, and then we subtract 1 from the n. Okay? So as an example here, if I have, say, an x squared, the derivative, and by the way, the one way that we can write this is the derivative with respect to x of x squared would be 2 times x to the 2 minus 1. Okay? So we bring the exponent down as a coefficient, and then we subtract 1, so now it is 2x to the first. Okay? If we have the derivative with respect to x of, say, just an, let's say an x to the negative third power, 1 over x cubed, you would rewrite it as x to the negative third. Okay? And that's something you're going to have to do a lot here as well. In fact, let me just, for reference in the notes, let's do that. If I have 1 over x cubed, I would rewrite that as x to the negative third. So then I bring the negative 3 out in front, and if I subtract 1 from negative 3, I get negative 4. Okay? That you should simplify, so it would be negative 3 over x to the fourth. Rule of thumb here, always simplify negative exponents, always simplify complex fractions, fractions within fractions. You do not need to simplify fractional exponents back into radicals. Okay? So for example, just another one with the power rule. The derivative with respect to x of the square root of x. The square root of x is what power? The 1/2 power. Okay? So this is x to the 1/2. So I bring the 1/2 out in front, and now I have 1/2 minus 1. So I have 1/2 x to the negative 1/2 power. Okay? Well, that has a negative exponent, so I will simplify that. That's 2x to the 1/2 on the bottom, or 1 over 2 root x. Okay? Now, this is all just algebra, simplifying negative exponent and fractional exponent. Okay? The calculus is just occurring right here in this step. from x to the 1/2 to get the 1/2 x to the negative 1/2. Okay? These are rules that you're going to use so many times you'll know how to do them in your sleep. Okay? Alright, so that's another rule. Our third rule here is a constant times a function. Okay? So, if I have a constant times a function, if I take the derivative, notice the constant doesn't change. Now, notice how this is different than the first rule. The first rule was just a constant standing by itself, like a something plus 5. When you do the derivative of 5, it's 0. This is different. This is something like, if I take one of the examples up above here, let's say instead of just an x squared, let's say I had a 5x squared. Okay? The derivative of 5x squared, I can think of, I'm not going to be writing this down, but I'm at least thinking of it as 5 times the derivative of x squared. Well, we already figured that out back here. The derivative of x squared is 2x. Okay? So this is 5 times a 2x, which is 10x. Okay? So as you're working this out, you can just think of this. You can jump right from here to the end by just saying, okay, well 2 times 5 is 10, and then 2 minus 1 is 1, so x is to the first. So it's 10x. Okay? If I had, for example, the derivative of 7 over x cubed. Well, that was that negative third power. The derivative of 7x to the negative third. I would multiply the 7 by the negative 3, so it's a negative 21. X to the negative 3 minus 1 is negative 4. Okay, so that's a negative 21 over x to the 4th. Okay? And then finally we have the addition rule or subtraction rule. It works for both. The addition or subtraction rule is saying that if I have multiple functions added together, I can simply take the derivative of each piece and add those derivatives together. Okay? And this is how we get polynomials, derivatives of entire polynomials. You just take each piece at a time and find it that way. Okay? So just getting into the practice, I'm going to run through a couple of the practice ones here and then give you guys time to work on this practice. Okay? So for example, let's do B in this case. Alright? If y is pi x squared, okay? If y is pi x squared, then the derivative of y with respect to x is going to be pi times the derivative of x squared. Okay? What's the derivative of x squared? 2x. So that would just be 2 pi x.
So, when it asks you to find d over y over d over x, just asking if it's just a different way to notate it?
Yes, and that's why, that's one thing you guys need to get used to. That's why I gave you so many of these different ones. Here it's saying find dy dx. Here it's saying differentiate with respect to x. Those directions are telling you to do the same thing, just in different ways. Okay? There are actually a lot of different ways that we could ask you to find the derivative. Okay? Here's an example, 3b. Now, this is where I told you guys that there are certain rules, like a product rule. Okay, here we have multiplication. But doing the product rule here is not the best path, because what is x times x to the 1/2 power?
to the 1 to the 3 half?
Yeah, that's x to the 3/2 power. So now, the derivative of that, with respect to x, would equal what?
3 half x to the 1 half.
3/2 x to the 1/2. Okay? You bring the exponent out in front, you subtract 1 from the exponent, and you've got it. Okay? And I don't care if you leave it as x to the 1/2 or if you make it back into a radical x, 3/2 radical x. That's acceptable too. Okay? So, with all of these, you have to think through and use the rules that I've given you so far here to do them. All the ones that I've given you can be done just with those first 4 rules. Okay?
What do you mean by the gradient of the tangent for question number 4?
Okay, that's a good question. So, the gradient of the tangent. Gradient is another word for slope. Okay? Gradient is another word for slope. Now, we said that the derivative gives us the slope of the tangent line at a specific point. So let's look at, let's look at D here, okay? If I want to find the slope of this graph at the point 2 3/2, okay, then what I need to do is I need to find dy dx. Okay, take the derivative. Now, we don't know how to take the derivative of this as it's written. But how could I rewrite this?
X to the negative 1.
Okay, if that x is on the bottom, that could be x to the negative 1, but then it would be times this.
2x squared over x minus 5, right?
Okay, yeah, we would either write it as a negative 1 and then you would want to distribute it, or what Dylan just did is maybe a little bit easier. Okay, split this into 2 separate fractions and rewrite it in a way, so now that's just a 2x minus 5x to the negative 1. Now I've rewritten it in a way that I can use those rules for. Okay? So the derivative of 2x is
4x. 2x? Wait.
what's the exponent of x here?
1.
1. So 1 times 2 is 2. And then x to the 1 minus 1. That's x to the 0.
1. It's 2.
Yeah, so it's just 2. Think about it. If I had the function y equals 2x, what is that?
X. It's
2.
Y, no, what is the function y equals 2x, guys?
Linear.
linear.
It's a line, right? What's the slope of a line? The slope of a line is constant. So it makes sense when you take the derivative of a line, you get a constant.
I was looking at 2x squared.
Oh, yeah, it's this one right here. Okay? So now we have minus 5x to the negative 1, so what's the derivative of that?
Minus
5 x to the negative 2.
Yeah, positive 5x to the negative 2 power. Okay?
That it?
Well, so that's the derivative of, and that will tell us the slope of this graph at any point.
Okay.
We want this specific point when x is 2. Okay? X equals 2. So, the derivative of y for x equals 2 is going to be 2 plus 5 times 2 to the negative 2 power. Well, that's over 4, so 2 plus 5 fourths, which is 1 1/4. That's 3 1/4. That's the slope of the tangent line at the point 2 3/2. So basically you're just doing one extra step. You're taking the derivative and then plugging in the x value. Okay? Alright. These ones take a little bit more thought. I want you to really think through number 5 and number 7. I'm not going to do either of those, okay? Because I'm going to give you the rest of this time here to work your way through this. Work in some groups, all right? Throw ideas off of each other and really think. These last 2 problems are really the types of problems that you want to be able to do in the IB, okay? You're not going to, rarely will you ever be asked to just, hey, what's the derivative of this function? Occasionally they'll give you one and they'll say, show that the derivative equals this. And you'll have to show the rules and do the proof, okay? But more often they're asking you to do something that you have to use the derivative for, okay?